Okay.
All right, take it away, Dave.
Hey, so today we're going to look at Kubernetes Goat, and I have this set up on O'Reilly Cat Coda. If you want to actually find out more about that, you can actually go Google Kubernetes Goat, or you can go to this URL and get some more information about it. So basically, we're going to start looking at Kubernetes Goat. This is designed to be an intentionally vulnerable cluster to learn Kubernetes security practices. Something to note, some of these scenarios use something called Helm, and you may have seen that before in other documentation. Helm is essentially a package manager for Kubernetes. It allows you to add different features into your Kubernetes infrastructure. So let's go ahead and get started. So the way that this works is the guy has created a guide, and when you're in the Kubernetes Goat, you actually move to these different services and you choose to use them. So in this case, we're going to try sensitive keys in the code base, and then if we have time, we may do Docker and Docker exploitation. So we read the scenario, and the scenario guide actually has step-by-step that you're going to go ahead and do, but we're just going to kind of go along with it here. So developers tend to commit sensitive information in version control systems. As we move to CI/CD and GitOps systems, we tend to forget identifying sensitive information in the code and commits. Let's see if we can find something cool here. So it says to get started, we go to this port. So how do we actually do that? So we'll go ahead and we'll click custom port, and Cat Coda goes ahead and opens something new, and we'll click display port, and boom, now we're actually at the site, just as it says. And so it says that we need to go to .config. So what is that, you're asking? Well, if you have a server, especially a web server, and you are doing something like Git, you can actually display that path with a backslash. So slash git will bring you to that file. So it cannot get the Git. But if we go to config, we can see that we actually do have some information there. So there is a Git repository that we can respond to. We're going to go ahead and go to our terminal, and let's go ahead and clear our screen. So one of the things the scenario is going to ask you to do next is run git dumper. Git dumper is a tool that allows you to dump a Git repository that's stored on a website. So we're going to go ahead and git clone. And I've gone ahead and followed the guide. And the guide said to go here to get git dumper. So I've gone ahead and done that. So now I'm on GitHub. I click clone, click the little copy button to get the Git URL that I'm going to use. I'm going to go into my control plane terminal, and I'm going to go ahead and clone it. Cool. So now that that's there, I'm going to go ahead and cd into git dumper. And I'm going to run a dir. Now, I might think that I should just run the git dumper py the way that the scenario file tells me to. That is wrong. Whenever you download some new software, it's always a great idea. If they have a README, the developer put it there for a reason. So let's go ahead and cat that out. And boom, it says, no, don't do that. You're going to just need to install pip install git dumper, or you can build from source and do pip install requirements. I'm lazy, so I'm going to go ahead and do the first thing that the developer said to do. If that fails, I'll do the next thing. So they want us to do pip install git dumper. And I'm going to go ahead and do that. It looks like it's going to go out to wherever the pip repository is and download the information for us. The next thing it says to do is run the line like this. All right, that's fine that that's what the scenario said, but that's not the name of the command. The name of the command is git underscore dumper. Just because the documentation was written this way doesn't mean that that's actually the way that it's going to be. So let's go ahead and run it. So we'll do Python 3, and we'll follow git dumper. And now we're going to go ahead and go to that localhost. But Dave, you were clicking on something completely different that had a bunch of other long host information. That's all the way that CatCoda works. They host this on their own little cloud infrastructure. But for the scenario itself, if the scenario has it routed to localhost, you'll be able to access it through localhost. So then we'll do git. And now, since we were good little script kiddies and we read what it actually said, it says URL and dir, and that's our output directory. So we need to do that. So here's our URL, and we now need to provide it a directory. So let's go ahead and do what it suggests, which is K8S goat git. And it's going to go ahead and fetch all the objects for us. Cool. So now that that's complete, let's go ahead and cd into our directory. K8S. Cool. And then we'll clear our screen and we'll do an ls/la. All right, so we see we have a hidden file. So that's git. So this means that we have brought down the git repository. So now we can run a git log, which will read any of the commit entries that were stored within the git repository. Awesome. So now we see a bunch of information. And it looks like there's a lot of good stuff in here. So we're going to continue to scroll through. So it says it updated the configs, updated the endpoints, updated a bunch of different stuff. And one of the things that we are wanting to look for is hopefully we're going to find their keys. So it looks like that was probably done with include environment variables, because that's typically what you need to do. You need to feed to your Kubernetes infrastructure some way for them to access the different nodes. And the way that you do that is through maintaining a set of secrets. So let's go ahead and just follow what they said. So they're going to go ahead and check out an old git hash. So let's go ahead and check that out. So it's not in the tree. So why isn't it in the tree? Because the documentation that I'm going from might not have been correct. So let's actually grab the one that we see on our screen. Again, I did that because if you were following along with the scenario, you would have just copied and pasted this information and it would have looked wrong. So cool. So now we are in a detached head state. So we're going to do an ls-la. And we see that we've got something that says env. So before we do that, always good to actually read what you have done. This has shot me in the foot many a times. So it says we're in a detached head state. You can look around, make experimental changes and commits, blah, 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 and discard them if you want to create a new branch. So what did we basically do? So when we did a git checkout, we decided to roll back our git tree to a place where there was an old commit. Every time you do a git commit, it gives it a hash. You can walk back in the tree if you tell git checkout the hash value that you want to look at. Boom. And so we did a checkout. And now we've cat the env. So what did we actually see? So now we actually see the access key itself, right? And that's great, but that's bad. This should have been done in a different way. You should have been storing your environment variables through some part of third-party system in order to store those secret keys. This is just showing you that this is a bad way of doing it. Next, so sometimes we ideally have access to pods and containers. And we can also perform analysis on that container as well. So the way that we do that is we're going to go ahead and run this export command. And we're going to do that because a couple of reasons. Let's go ahead and pull the screen thing all the way over like that. All right, so, whoa, export pod name. Kubectl. Kubectl is the way that we interact with Kubernetes. Think of this as just like Git. You have to say the name of the command and then any sub parts of the way that the command behaves. And this way kubectl is saying we're going to get a pod, and we're going to get the namespace at build code. We're going to set a JSON path for that metadata. So let's go ahead and do that. Now that we have that, we can actually execute into the pod. So we're going to do cube, and this is all part of the scenario, right? I'm not just making this up. This is method 2 from that scenario guide. If you're on cat coda, you could just go here and you would follow along. Had you read all the document, if you read all the documentation, it'll tell you to have the scenario guide open on another screen. exec, so kubectl execute, and then we're going to ask it to execute it. And we're going to say the new variable that we created. How do we know if we have that variable? We can type env, and we can see that we have set one of those paths into our shell. So now we can just go back. We'll execute that again, make sure it's there. Cube ctl exec it, and then we'll do the pod name, and then hyphen, and then sh. We're doing this because we want to actually log into the pod. Cool. And so now that has changed. If we type ID, we can see that we have all these different memberships. We're essentially root inside of our pod now. Do a ls-la. So we'll list all the files, give it some nice printing of like what's the names and the directories and when they were created, and then show me everything that's hidden. In this case, we want to go ahead and execute trufflehog. What is trufflehog? So there will be a lot of different things if you're going through cat coda that you're not familiar with. Trufflehog is essentially a security tool, and what it will do is it searches through Git repositories for secrets, and it digs deep into the commit history and branches, and this can find any secrets that you've accidentally committed. Why are we doing this? Because we've just proved that we have a pod in production that is storing environmental keys, and we don't want that. So let's go ahead and just run what they say. So they say you can just run trufflehog. And then do a dot. And if we run the dot, it'll do it through this whole directory. So at this current directory that we're in, let's give it a little bit of time to run. And it's going to look through. If we put a verbose flag on it, we probably would see more, but just like a lot of different things, sometimes you're not going to see output. So you kind of just have to be patient. And there it goes. All right, cool. So it's gave us a reason for high entropy. And then it said that I found a bunch of different keys. So it said that, hey, at this hash for this commit, in this path for EMV on this branch, include custom environment variables. All right, cool. But those are in clear text and anybody can do anything with them. And now I can log into your AWS instances and cause mischief. So if I was a user and you gave me an app running on Kubernetes and I had the ability to access it, I now have full control over your Kubernetes environment. Really bad stuff. And you definitely should not do that. Do we have time for one more, or do we want to call it quits there?
Yeah, that's really
All right,
good.
cool.
Let's stop that and let's shelf your other demo for next week.
No
But
problem.
yeah, that was really good. Thanks, Dave.
Yeah.